Hello, hello. So, for this video, we are going to practice a couple different things. We're not only going to be able to identify the reduction and oxidation in an equation, like what is being reduced, what's being oxidized. We're also going to talk about which one's the reducing agent and oxidizing agent. So we're going to do a few things in this video. So I actually have an easier one on part B, so let's, or the second part here. So let's do this one first, shall we? So, if you remember, Leo says grr. So if you lose electrons, you're oxidized. If you gain electrons, you are reduced. So, and remember, electrons carry a negative charge, so that's going to come up a lot. So we're going to have to follow some of our rules that we made. I'm going to go get a different colored marker. Yes, there we go. So let's identify the oxidation states of the products and the reactants. So we're going to have to consult our rules that we have, that handout. So carbon is by himself, and he doesn't have a charge. So he has an oxidation charge of 0 as of right now, right? O2, again, he's by himself. He does not have a charge. He's elemental is what they call it. He's elemental oxygen. No charge, right? So let's figure out CO2. We're going to do some scratch work down here, right? This is going to be our scratch work. CO2. And if you guys remember in class, this is how we set it up. Since there's no charge on CO2, it all has to total out to 0. Right? So, I don't have a rule for carbon, but I do have a rule for oxygen. What's its oxidation number likely to be? It's likely to be -2 for each of them, right? And if oxygen is -2, that means it's carrying, and there's 2 of them, a total oxidation number for O is going to be -4. Correct? So what does carbon have to be to balance out that, to total out to 0? Carbon has to be +4. It has to bring a total of +4, and since there's only one carbon, each carbon is +4. So carbon has a +4 and oxygen is a -2, right? So let's figure out which one is reduced, which one's oxidized, and then we're going to identify which one is the reducing agent and oxidizing agent. So carbon went from a 0 to a +4. Now did it lose electrons or gain electrons? If you gain electrons, you are becoming more negative, correct? If you are gaining negatives, you are becoming more negative. That is not the case here. Carbon went from 0 to +4, so it must have lost electrons. So lost electrons, right? Carbon lost electrons. So according to this, if you lose electrons, you are oxidized. Let's look at oxygen. Oxygen went from 0 to a -2. You have to gain negative charges to do that, correct? So oxygen gained electrons, and according to Leo says grr, that means he is reduced. I can spell, by the way. Alright, so that would be a question on the exam. It'd be which one was oxidized, which one was reduced. That would be a good question. But then we have a third, or another thing that we could ask. I could ask, is it the oxidizing agent or the reducing agent? So remember, it's opposite. So if you're oxidized, you are the reducing agent. It's backwards. So if you're reduced, you are the oxidizing agent. And if you remember what we studied in class, oxygen is usually an oxidizing agent, right? So that makes sense. So carbon is oxidized because oxygen is a good oxidizing agent. Yeah, that makes sense. Oxygen is reduced because carbon's a good reducing agent. So that's kind of how that works. So let's boogie on up here. So this could be a question. I could ask you which compound is reduced, which compound's oxidized, or I could ask you which compound is the reducing agent, which compound's the oxidizing agent. So we kind of did all that here. Now we're going to go up here and practice some more, shall we? Now I don't care about these numbers in front, these coefficients. We don't. What do we care about? The formulas. when we're determining oxidation. So let's do the easy ones first. Manganese is by himself, right? So he has an oxidation number of 0. What else is by itself an elemental? Aluminum. So he's also 0. So that's easy, sort of, right? So now let's do basically do this kind of treatment with aluminum oxide. So we're doing a little side work here. Aluminum oxide. This has to total out to, you guessed it, 0. Why? Because there's no charge here. If this were, say, a charge of -2, this would have to total out to -2. If this, remember polyatomic anions and polyatomic ions? They had the charges. This is a compound that does not have a charge, so it has to total out to 0. I don't have a rule for aluminum exactly, but I do have one for oxygen, like a more solid rule. This will be -2 each. And since there are 3 of them, a total of -6. So to total out to 0, aluminum has to bring a total of what? +6. Does that mean every aluminum is 6? Let's look. Oh, there's 2 of them. I need 2 of them to bring a total of +6. So each of them is what? A +3. Alright, so now it's kind of making sense. So, +3 for each aluminum, and each oxygen is -2. Handwriting. 0 here, and then we just have to figure him out. So let's keep practicing. So manganese oxide has to total out to 0. So oxygen I have a rule for, not manganese exactly, right? So oxygen I have a rule for. I'm going to say each oxygen is -2. Total of -4. So manganese has to bring with it what? A total of +4, right? Yeah. And it looks like there's only 1 manganese. So that manganese, he himself is bringing all of those +4s. Oxidation number. So we'll write that up here now that we solved for that. Manganese is +4, oxygen is -2. Okay, perfect. So now that we've done all the scratch work and we know this, we know that aluminum went from a +3 to a 0. Do you have to gain electrons to go from a +3 to a 0? Yes. You have to gain negatives to go all the way up from a +3 to a 0. You're basically decreasing in your charge, so you have to gain electrons. So this, gain electrons, right? How about manganese? We went from a 0 to a +4. To go from a 0 to a +4, you have to lose electrons because you're becoming more positive. Losing a negative is the same as becoming more positive. So you have to lose electrons. So, by the rule Leo says Gur, gain electrons reduced. So this was reduced. This was oxidized. So this must be the oxidizing agent. I can spell agent, and this must be the reducing agent. So that was quite a bit of practice. We practiced a whole bunch of things. We practiced not only determining the oxidation number of elements within a compound, but we also determined how to identify reducing agents and oxidizing agents after we determine what's reduced and what's oxidized. So I do hope that this helps. Good luck with that.